Okay, Unit 10.1, chemical reactions. And what are chemical reactions? Whenever you have any type of elements or compounds that join together, they react chemically and they rearrange themselves. The atoms in those compounds rearrange themselves to form a new type of product. Now, let me be real clear. New matter is not formed. The matter that we start with is the same amount of matter that we end with. Okay, it's just that the atoms rearrange themselves. You cannot create something from nothing, but what you can do is rearrange the atoms to form a new type of product. And we express these reactions through something called a chemical equation. And chemical equations follow the basic structure. On the left-hand side of your equation, you have the reactants, okay, your starting materials, and on the right-hand side, you have the products, your finishing materials, and you have an arrow between them, and the arrow means yields. Okay, so let me go ahead and give you a better definition here, and I'll go ahead and try to zoom in. Okay, and this says a chemical equation states that the substances that are present, the substances that are present before the reaction starts, i.e. the reactants, and the new substances that are formed as a result of the process, i.e. products. Okay, I'm having workers out there. There are workers out there that are distracting me a bit, but here, well, I'll read it one more time. The chemical equation states that the substances that are present before the reaction starts, i.e. the reactants, and the new substances that are formed as a result of the process, i.e. the products. Okay, it states both of those things, the substances before and the substances after. Okay, that's a chemical equation. And like I said before, it's really important to know that these atoms rearrange themselves. Okay, nothing new is formed out of nothing. Okay, so you can't take nothing and form something. Atoms that were there before are going to be the same atoms that are there after. They're just going to be in a different form, maybe in a different state, maybe from a liquid to a gas, but the same amount of atoms is still going to be there. Okay, and that's called the law of conservation of mass. And here's what it says: in any process, matter is neither created nor destroyed. So the total mass of a system before the process is the same as it is after the process. Therefore, the number of atoms of each element must be the same in the reactants as in the products, but might be arranged to form different compounds. We balance a chemical equation with coefficients to represent how matter is conserved. That's a lot to write. I'm going to go ahead and put it on the screen right now. Okay, so how do we use these chemical equations? Well, there's a few different ways you might see it written. The first way might be as a word equation, which says magnesium ribbon plus hydrochloric acid solution yields hydrogen gas and magnesium chloride solution. Okay, so there's a few different things going on here that you can a few different hints that you can take away from this. Okay, well, the first thing is magnesium plus HCl yields hydrogen gas plus magnesium chloride. So here's what you can do. There's also the states of this reaction are also given, but you may not see it. It might be a little bit hidden here. Okay, but here's what you would do. Here's how you would write it. Magnesium ribbon would be Mg plus HCl yields hydrogen gas. Remember, hydrogen is diatomic, right? It bonds to itself, plus magnesium chloride, MgCl2, magnesium chloride. How did I know all of that? Well, you can look on the periodic table and figure out this at least. You should know that hydrogen gas, and I'll tell you this right now, is always diatomic. Okay, always. If you're going to write hydrogen by itself, you have to write it as H2. HCl is hydrochloric acid. You should have learned that from the last unit. And magnesium is just magnesium. You can look on the periodic table. I'll bring up a periodic table right now so we can look at magnesium chloride together. Alrighty, how did I know magnesium chloride was MgCl2? Well, I know that magnesium is a group 2 element, so it forms a +2 ion, and I know that chloride is a group 7 element. It forms a -1 ion. Okay, so Mg with a +2 needs 2 of these chlorides to cancel it out. So that's MgCl2. Now if I were to write this out, if I were to write out the basic equation, it would look exactly like this. Now there's a few other things I could do here. This says magnesium ribbon. Okay, so what is a ribbon? Well, it's just it's a sliver of metal. So what state would that be in? Well, it would be in solid form. Okay, hydrochloric acid solution, what does that suggest? Well, solution suggests that it's in aqueous form. That's the state that it's in. Hydrogen gas, well, that just tells you straight up that it's in gaseous form, and that's a G there. Okay, so S for solid, AQ for aqueous, G for gas, and magnesium chloride solution also tells you that it's aqueous. All right, so you can also, by reading this, you can also figure out what state all of these chemicals are in. Okay, so there's that. The problem with this is that it is unbalanced. If you look, there's not the same number of atoms of each element on each side of the arrow. And what do I mean by that? If I look on this side of the arrow, on the left side, there's only one magnesium here. But on the right side, there's also one. Let's go to hydrogen. As far as hydrogen is concerned, there's only one hydrogen on the left side of the arrow. On the right side of the arrow, there are two hydrogens. There are two hydrogens. Okay. On the left side of the arrow, there's one chlorine. On the right side of the arrow, there are two chlorines. So these two, hydrogen and chlorine, do not agree with the amount of hydrogen and chlorines on this side of the arrow. Okay. So you've got one H here and two there. You've got to make sure there's two H's on this side of the arrow. How do I do that? I can put a 2 coefficient in front, and I now have two H's. I also have 2 times your Cl's, which is 2 Cl's, and that agrees with what's going on the right side of the arrow. So now this equation would be balanced. Okay, and why don't I have you do this? Why don't I have you do this? Take that 2 off there and write the balanced equation underneath. That way you have the unbalanced here and the balanced underneath. So let's go ahead and do that. Mg plus 2HCl yields H2 plus MgCl2. Okay, that is your balanced equation. I don't, balance complete ionic and net ionic for our purposes is going to be too much. Okay, so we don't have to worry about that. I'll make sure that those aren't on the test. Okay, so now you can also combine, you can categorize chemical reactions into different types, into different categories. Okay, so there's combustion, decomposition, synthesis, single replacement, double replacement. And I'm going to teach you right now how to identify each one of those. Okay, a combustion reaction is also called burning. Example would be ethanol is burned in air. Well, let me give you an example of what a combustion reaction looks like. It would be a hydrocarbon, so hydrocarbon plus O2 yields CO2 and water. Okay, this is a combustion reaction, some kind of a hydrocarbon. And what is a hydrocarbon? It's simply a compound made of hydrogen and carbon and oxygen. Okay, hydrocarbon plus oxygen yields CO2 and water. That's how all of these combustion reactions look. Okay, so let's go ahead and try that. Let's say ethanol is burned in air. Ethanol is C2, H5, OH plus O2 yields CO2 plus H2O. This is unbalanced. That's unbalanced. But let's look. This part right here is exactly as I told you in the example, right? Something plus oxygen yields carbon dioxide and water. A hydrocarbon, well, this is a hydrocarbon. It's got hydrogen, carbon, oxygen. Okay, that's a hydrocarbon. So all combustion reactions are going to take this same basic form. Hydrocarbon plus oxygen yields carbon dioxide and water. Okay, I'm going to move on to the next video, and we'll try to finish these notes in 2 videos.